Hello everyone, welcome back. Today we will be solving one LeetCode question, 3-sum. Given an integer array nums, return all the triplets such that their indices are not equal to each other, and the sum of these triplets will equal to 0. And notice that the solution must not contain the same triplets. Let's take a look at the example. Here is the array, and our answer is -1, -1, and 2. So here -1, -1, and 2 sum together equal to 0, and their indices are not the same. Also, -1, -1 here, 0, and 1 here, they sum together equal to 0, and their indices are not the same, and this triplet and this triplet are not the same too. Let's take a look at another example. Here we have the array. There's no element in this array can sum up to 0, so we can just return back the empty array. How do we solve this problem? The question is very similar to the question 2 sums, except now we want to sum 3 elements together instead of 2. For 2 sum, we can first sort the array, and then we use the left and the right pointer to move to the target element. We can also apply the same technique to this question as well. First, we will sort the array, and then it will become this array. Since the question is about 3 sum, this kind of implies we need 3 pointers to get a whole of 3 elements. I will initialize I as a first pointer, start with the index 0, and j as the second pointer, start with the index I plus 1, and k at the last index. And we also need an output variable to store all the triplets that we can find in this array. In our example, I is here, and j is gonna be here, and k gonna be at the last index here. So to avoid duplicate, we keep moving I if the previous I is the same as the current I. When we have the triplet, if the next j is the same as the current j, we keep moving j. If the previous k is the same as the current k, we keep moving k back. Let's take a look at the example here. So first we will sum -4, -1, and 2 together. So the sum will be equal to -4 plus -1 plus 2 equal to -3. And -3 here is smaller than 0. So we keep moving the j pointer because we want to get a bigger element. So we move j here to be here. Now, -1 is the same -1, so we keep moving j again to this element. -4 plus 0 plus 2 equal to -2. -2 is still smaller than 0, so we keep moving our j to be here. Now, -4 plus 1 plus 2 equal to -1. It's still smaller than 0, so we keep moving j, but we don't want j and k to be at the same element, so we break out from our loop. Next iteration, I is -1, j is here, and k is here. So -1 plus minus -1, and k is 2. So this one will be equal to 0. So we store -1, -1, and 2 to our output variable. -1, -1, and 2. Then we will check if the next pointer of j is the same as the current one or not. Obviously it is not the same, so we just move j to the next pointer. And for k, we also have to check if the previous k is the same as the current k. If it is the same, we keep moving k. If it is not, we just move the k back only one step. Now we have -1, 0, and 1. -1 plus 0 plus 1 equal to 0. So we store these 3 elements in our output variable. -1, 0, and 1. And we move j to be here and k to be here. And we break the loop. And for the next iteration, I, we check if the previous I is the same as the current I. Of course, it is the same, so we have to keep moving I forward because we don't want to have a duplicate triplet. So we move our I until here, and j should be here, and k is here. 0 plus 1 plus 2 equal to 3. 3 is bigger than 0, so we move k back one step. So k should be here, and j should be here, and we break the loop. And this is our answer. This is the triplet. This is the unique triplet with the different indices. Let's code out the solution. First, we will have to sort the array in the ascending order, because we want to use the two pointer technique to move either forward or backward. It depends on the result of the sum. And we also need the output variable to store all the answer or the triplet. Now we will initialize the I pointer with the index 0, and we want to keep looping I from the first index or the index 0 until nums.length -2. Then we will initialize j with I plus 1 and k with num.length -1, and we will have another loop that loop from the j until k, because we don't want j to go beyond k and k to go beyond j. For our sum, it will equal to num_i plus num_j plus num_k, and we check if sum equal to 0. If it is, we want to store our answer to our output variable. So this one is going to be num_i, num_j, and num_k. These three going to be our triplet. And now we have to move the j pointer and the k pointer. Else if the sum is bigger than 0. If it is already bigger than 0, we want to move to the smaller element, which means k -1. Else, we want to move the j pointer to the next element. And then we have to move the I pointer forward. And at the end of the looping, we want to return back the output. However, this is not done yet, because we want to avoid the duplicate. In order to avoid the duplicate, we have to check if the I here is bigger than 0 and the num_i is equal to the num_i -1. If it is equal, we want to keep moving I forward, because we don't want to use the same I element. And the reason why we want to check if I bigger than 0, because if I is already at the index 0, there's no previous element. We want to check the previous element of the I. And what about j and k? So here, after we have the triplet, we also want to move the j and k, while num_j equal to the num_j plus 1. If it is equal to the next element, we don't want to use the same j, so we keep moving j forward. And while num_k equal to the num_k -1, we also want to keep moving k until we see the different k. And that's it. Let's check the result. So what is the time complexity for our implementation? We know that we have to sort the array, so the time complexity is n log n. Also, we can see that this is the first loop, and this is another loop. So this is going to be n squared. And for the space complexity, it's going to be O of n, because we store the unique triplet here. Hope you guys enjoyed it. See you next time.